Hello there again, my friends and neighbors, whoever's watching, not too many, not there, nobody looked at that video, not that important. Well, this seems slow. I hope my voice is going through, but anyway, I know that number is pretty small, about 5 maybe. So I need to come up with a more exciting sounding title for this. And one thing I noticed, actually, I want that back. Let's put this in a tray. If I'm clicking on these sorts of icons, I want that in there. And this is doing something too, but that's disk copy. That shouldn't have any use any noticeable CPU. Okay, so 6. But what did I want to say? I better pause. I'm gonna go to Google Plus. So I better pause this. Sorry, I don't know what's going on with this video, just in terms of whether the audio is getting picked up. But this is where I wanted to show something. This here view in Google Plus is not the view I saw it the other day. Maybe I put it, let's see, settings. But I didn't change my settings. Oh, but I wasn't me. Let's see, I want to change it to the other one, to the default. Where's that picture that had the boxes? Can interact, notify, receive, apps, customize. Oh no, not this. Cancel. Customize circles, no. Auto parents, no. Hashtags, I don't know what that is. Great. Maybe it's here. No, that's my profile. Certainly is. One of the ways of viewing that sort of feed is the word that people have been using since, I think, like the 1820s to get like the list of things going on from all your various things you're connected to. Well, that word doesn't exist here. We have this, which is home. Okay, I know. I would have called the last place I was at home. This looks more like a feed. But this might be a feed of only me. Would I know? No, that's someone else. Okay. So my home is my feed. This is my photos event. Well, my home feed is fine because these are nice big pictures, and you can read in particular, you can read the full text of the video's description, even if it's quite long. In the other view, which I can't seem to enable, these are small boxes, and it gets cut off at this point, and then it just says ... right? And you can put the cursor over it and hope and pray that maybe a little bubble will come up and tell you what it says, but it doesn't. The only way to find out what it says is to go in and click in. So therefore, if you want to catch someone's attention, you got to do it from this point. You got this many characters to grab someone's attention, which is what? About 30 characters. because it takes several characters to do the dots. The box is about this big, maybe 35. No, because it's centered, see, so it really, if the box is about square, this size minus and like internal leading minus 3 dots, that puts you maybe here. Let's say 40 characters maximum, not even, because there's the dots. Oh yeah, there's the dots. 35 characters. So saying C++ lesson number blah blah blah, right, is no good. This is the critical section for grabbing someone's attention. So I can't say anything like that is repeated in every title here. That can go at the end. It's got to be attention grabbing from the start. And I don't know, I'll think of something, because I think this might be quite entertaining, this one, if not informative. So it'll either be entertaining, or it'll be informative, or both. I still want to put that thing away. Right. Okay, now going back to where we were. Actually, let me just close this. What I did was, forget about those comments for a minute. I decided to generalize this concept of, because I had it already actually, to put this concept of thread and dialogue together into a single class called a modeless dialog. Okay, so a modeless dialog is like a dialogue, but it's also got a little internal thread that runs, and this hides the complexities of that problem inside. So you don't have to implement any thread proc. You just implement your dialog proc as usual, and it works. Here's an example of me using it. In this case, I'm just allocating one. Then this runs the dialog. It starts its message loop going. Now I'm trying to read that file, and at the end of the read, if the dialog is still active, when I call end to stop it from being active, assert that it ended correctly, and then delete it. And as far as this class, well, that's the entire class at the moment. All it does is dialog proc return false. Okay, so it's not very hard to use it. Just the same as the dialog almost. You have to be careful that it's not modal. It's like this line returns immediately. I think it might maybe return a bool. Not even. It could return a bool actually to say that it started successfully. This here could be returned. But probably when I wrote this, I thought, why return a bool? Emphasize the fact that this thing doesn't return anything just by making it void, right? Somebody tries to say, if run dialog equals such and so, then they're going to get an error. And that's one way to prevent bugs. Although it might be useful to have this return code, it's more useful for it to be an error to try to compare this function with a value. Because that's what we do with modal dialogues. Somebody trying to do that with this kind of dialogue would not receive an error in the comparison, but in the meantime the program would probably crash. That's also another way of indicating that something bad is happening. Okay, so now the result of that is, I bet you're dying to find out if that finally fixes the problem. If you remember what the problem was, The problem was it didn't seem to behave the way it did before. At least that's for me. It appeared as though when we did a modal dialog within a thread, that couldn't be right because we couldn't move not the parent, but the other window around, whereas I had remembered that even though it was blocked, I could still move it around, right? So I go to open something up, a big long file, and I haven't done anything about centering to position or anything. There's my little dialog, right? And this thing is dead. I can't move it around. I can move this around, but not that. I can cancel this even. Well, that in fact, that behavior, I thought that was the behavior before. I was sure that's what I'd remembered. And then I went and this is from several days ago, doesn't have any funny stuff. I try to open this big file. Notice I still can't move it around, see? But now it says this, and I can. That's what I remembered, not putting this together with the fact that until this thing comes up, you can't move it around. What's happened here, I believe, is that the real window prop is blocked. It's doing something, but it's blocked. And now the system has taken over the mouse handling in lieu of the fact that the window itself is dead, right? And this isn't going to kill it either. It can't be. This handling is not going through WinProc, and it's not in the same thread as WinProc. Can't be. That thread is hung at the moment. The system has to have created another thread. If there's some way I can debug this, we can prove it, I'm sure. Go to process, debug, attach debug. Use what we currently have. Oh, it won't work. It's well, we can still see what the count of threads is. Although there's going to be like 30 threads from the other thing, the common controls. All I got to do is replace this here with the debug version. Let's just kill it. Oh, doesn't matter. I want to see anyway. I built this here, and where it normally goes. Actually, I'm just making an installer with the debug version. Temporarily. Come on. Come on, open. It's looking for the association, you know. It's text file, I've already said. Never mind. Sources. Say debug. And I think it should pick it up. What do you think that's all about? Can you hear me? close, close it. Oh, it's this one. I thought I closed it. Retry. Alright. Now we can run it from outside the debugger. No batch files or anything. Alright. Now there's this thread. Cancel it. That one should be dead. And I want to attach debugger processes debug. This should just use the current source. Okay, now we're attached. We can break all. Oh, but that's no good. I gotta take that thing off. Look at it, it's still there. Oh, it's not responding. I got to that thing. I couldn't do it before. Maybe it was even doing that before. Alright, break all. Extract drive. Okay. What? Oh, it says dialog thread. That can't be right. That can't be right. Oh, hang on a second. This thing, why this says extract drive, I don't know. That is not the current function. The current function is called thread prop. This one is in probably extract drive. No, it's not. Okay, now I'm pretty sure I killed that dialog. Really should use peak message. Good. This function is not called common extract drive, I'm sorry to say. Wait. That's the name of the thread. Oh, I see. It's given this thread a name for some reason. The name it's given it is TS common extract drive. Don't ask me why. Now I'm pretty sure I pressed the cancel button. Oh, maybe I'm not quitting. No, while not equal to 0. This is wrong. I wrote down a new message loop and it's incorrect. It's supposed to say greater than or equal to 0 or something. I made the same mistake I made before. Oh no, that's right. While not true. Well, I don't even want that dialog. Anyway, so let me just get rid of it. It's mucking up the work. I can do that, eh? I declare a bool. Never mind. I suppose you could declare, assign, and return all in the same one step. Why not? It's kind of a dumb allocation, isn't it? Language allows it. Sometimes I find when the language allows weirdo things like that, and sometimes you can use weirdo things like that for some purpose. Like this could be an auto-releasing thing, maybe. No, can't think of anything. Where a declaration would be an advantage. Now this should be faster than it's currently going. Probably got, oh, I still got this bloody thing running, that's why. So, well, it wasn't indicated, but I bet you that could be part of the reason why. Okay, now I've built it. I want to make it installer. It's just that I wanted it associated so that I can run it by double click. This is the fastest way. Okay, now I want it to be not responding. Okay, now I want to attach debugger. Okay, it should be attached now. Now how about that? Well, there's definitely a second thread. Right? Here's the thing, the thread that's reloading the file. Now there's no way that it's processing those Windows messages, right? There's another thread, and maybe it's similar to that the thread that allows these things to move around when the process is hung. A system thread that takes over the non-client area. Because as it is, this thing is hung, but I can still drag it around. Right? I've invented a modeless behavior in a single thread. Impossible, right? It is impossible. That's not impossible. Ha ha ha. It is impossible. There has to be another thread, and it's just not being picked up by the debugger. So putting all those things together makes me realize that I have had this backwards, and that's given me an idea actually for a title. We had it backwards. We don't want what we want is a modeless dialog, right? The operation of loading the file is a modal dialog. The operation of loading the file is modal, like it can't. The regular operation of the program cannot continue until that file is completely loaded. So we've got it backwards. Our dialog shouldn't be running as a modeless dialog independent of the program. The load here, this should stop, and there should be no more running of the program until the file is read in. What we can do is we can make another thread that reads the file. You see, and then run a modal dialog that's waiting for the file to be completed. So at this point, we say start. Our outline of the code would be begin file read, and then pass the file name, blah blah blah, and call back, and then DLG progress do modal. See what I'm saying? Now, if someone presses the abort read button on our modal dialog, then what we do is we instruct this thing to not continue reading, and we wait for it to complete its last read. And once that's done, then we allow this dialog to quit. So the process of quitting this dialog involves terminating the read, and then terminating the dialog, and then continuing on with the program. At the end, we would have passed a buffer in to here, and by this line, you should be able to stir buffer safe, right? Otherwise, this thing is being used by a different thread during the file read, and we can't use it. But if we work it out such that this modal dialog ensures that this thing has stopped, that the file reading thread is completely dead and killed before exiting, then it's safe to go on and read the buffer. Okay, so we had it backwards. So this is another example of starting out on the wrong foot in a quick, hacky way, and quickly arriving at the correct solution, not because of any genius in planning, but just by noticing that everything's wrong, right? Noticing that you've done something wrong helps you find the correct solution quicker than trying to think it out theoretically and find the theoretical best solution in your head. I find, anyway. I find it's quicker to just start out, just do like my pal Steve told me. Just start doing it, and the correct answer is going to come. And it's going to come a lot faster if you start out on the wrong foot, as I'm going to say in the title, starting out on the wrong foot and ending up on the right foot in the end. So now I'm going to upload this video clip, and I'm going to rearrange this, and unfortunately I won't need this class, but it's handy, it's useful. You saw it being used, and you see it's very easy to use. Maybe I should just quickly go over how this thing works since we're here. Hang on a sec. Time. Okay, there's enough time. Modeless dialog is the merging of two ideas, thread and dialog. And You'll note that this does not require any virtual derivation, strangely enough, even though there are virtual functions, because these two things don't derive from a common ancestor. Right? This here thing is a structure, a window type structure, that just handles some of the internal Windows calls to do with drawing windows and boxes and whatnot. And this here is a process type object, similar to our own process. So this is a process, and the process has within it a dialog. This dialog could have been a member of this, but it's just as easy to derive from both. In fact, it makes it easier to use, and not only that, this thing really is, in every sense of the term, this type of object, and you'll see why in a minute. It has similar characteristics and features. Okay, now the construction I've just passed off to TS Dialog. Same list of functions. Get return code, this is to do more with the process. The process has a return code, and you can retrieve a return code, although it doesn't actually come from the process. These thread things don't. It turns out I don't provide an exit code function for these threads. I could, but I don't. So this one is like a thread that has an exit code. Again, run is just begins that process running. Okay, and the word dialog is unnecessary. It could just say run, and that sounds a lot more like NFC. I could rename it to that, but and it doesn't sound right. If it was run, this would probably have to be stop. Just end is too ambiguous. And dialog's not ambiguous at all. And notice that these two words have the same number of characters, so everything lines up nice. Whether or not one of these objects is active, it's the same question as asking whether or not its process is running, and that's what this function returns. Now these are just aliases. They always do our call run dialog. Somebody might guess that this is what you're supposed to call, or they might guess that this is what you're supposed to call, although this is a complete misnomer. This is an oxymoron, and this is really correct. Okay, now how does it work? Well, you can see that all this does is say start. And as far as the code goes, get return code, you can sort of guess what that might look like. Right, there's some mutex guarded code that's returned. End dialog. Well, let's have a look. Here's where you're going to see that there's a difference between ending this kind of dialog and ending a modal dialog. First, I'm just going to scroll quickly through. See, there's lots of code there. So that means that there's more going on here than just a simple call to end dialog. So therefore, we should check to see what start does. Well, start is the thread part, using the thread start, which calls begin thread ex and waits for the So for a signal to get set before returning. So that means we should be looking at the thread part of this object, which is thread proc. So in order to understand start, we have to look at this. And then we can try to understand end. Here is the thread proc. Now I think I had it wrong before in my old code. I prefer to do it this way. Create is a new function I added to TS Dialog, which is used to create a dialog but don't run it. It could be only a function of this, but there may be occasions where you don't want to use this class, but you still want to create a dialog, and you don't want to run a modal loop. So all this function does is first assert that it hasn't already been created. Call create dialog param, which is a new function that you probably don't know. Can I double colon this? Probably not. I mean, it'll allow me, but this is going to be a macro. See? I hate when they do that. Now, create dialog param. I don't even need to probably to explain to you what all this does. Normally, the function we call is dialog box param, right? So let's do modal. See, dialog box param and create. I should put them together. Let's create go. The same file. Okay. Now they're side by side. You can see the difference. This here is a thing that does this, then runs through a modal loop, and then returns an exit code, right? Here we're just not doing the loop. We're creating the dialog, create dialog param, and returning immediately. So at the end, when this returns, the h1 parameter will have been filled in, unlike in the case of TS Dialog. We don't know what h1 is until we get a call to init dialog. Well, in fact, init dialog does get called by this in either case. Just like with create window, you get a WM create message inside of your window proc, which allows you to determine the h-win. Similarly, this thing does the same thing. So the dialog proc will have been entered and returned from at least once following this create. But the dialog won't be up and running yet because we won't be in a message loop yet. And it will have been created hidden, hopefully, because you wouldn't want to have it shown before you want to start using it. Okay, now where were we? Modeless dialog, thread proc. So we create the dialog. Now, because in this case we're in the thread proc, we're ready to start running it. After creation, this might fail, in which case two things have to be done. One is we have to create the dialog. Two is we have to tell the thread that's running this thing that the thread proc is started. And in this case, we're starting, and then we're going to return immediately. In the second case, where the create succeeds, this could be, doesn't matter where this is, as long as it is done after the create, meaning that the hwind is valid, then we can allow, this comment belongs with this. The comment I've written here, don't let the calling thread resume until the window handle is valid. So we're just let the one that's waiting, let them keep waiting until we have a valid window. Now we're showing the window, update window like usual, and this is just a regular Windows loop, a message loop. As we would normally run a message loop, this typically, as in this case as well, this function got called from within a dialog procedures message handler, right? So that typically that loop is now dead. So we start a new message loop in a totally different thread. Whether or not that other one is dead or not dead is irrelevant. We're in a different thread anyhow. We need our own message loop. So we start a message loop. And this is the standard message loop. While get message is not 0. This should never be -1. If it is -1, that's an error. We return. It is window. This checks to see if it turns out that checks if hwind is a valid window, and if the message happens to be a dialog message destined for this dialog, this object happens to be a dialog, then the calling of this function will have the effect of processing that message, and it will return true. So in that case, there's nothing to do. Otherwise, we just translate and dispatch. So other things, sub-windows, other controls within our process will receive their messages as normal. And that's all there is to the dialog proc. The thread proc. It runs a message loop, just like do modal does. And that's it. That's all there is to the dialog thread proc. Dialog proc is something that you implement. Now for terminating the dialog, because it's a modeless dialog, and as in the example, as in this example, I get rid of these comments. This run dialog returns immediately. There's no way, it's not a modal thing, it's not a modal dialog. So we're not waiting for anything. The thing is up and running and doing its thing. So if we want to call, if we want to call end dialog, rather than, let's say, if it may have been done through a message button click in the dialog, or we can call it externally, right? Those are two separate cases, two different threads calling into the same function. So therefore, we need to protect, if we're going to look at the return code and set it to some value, then we need to protect our return code with some kind of synchronization object, which is a mutex. and I use the mutex locked struct, which I changed, by the way. This used to derive from T, but I want to use it for something, a basic type T, not a class, but an int in this case, so I can't derive from int. So I made it a member instead. It's all the same, just need a way to reference the internal object so it looks like a T. Okay. Details, those are details. Now this iret code, even though it's a structure, behaves in every way just like a regular old integer, so I can check its value. This check, and I could put a breakpoint here to show you, that will invoke this here, cast to integer value, right? Assignment is done here, so there's a way to assign and there's a way to test. Either way, synchronization is done this way externally. Let's see now. If that thing, if we open a small file and we don't stop the dialog, it'll happen, right? So I can put a breakpoint here and open a small file, and this should be true. So let's try it, and you'll see we'll go to end dialog and test will invoke the correct function. It has to. If it doesn't, then I made a mistake. This here is checking if the thread is active. And as long as I don't press the cancel button, it will be. We'll just choose a small file. Okay, here we are. And here's our call stat. Okay, we're loading the file, and that led us to read file, and now we're trying to call end dialog with ID OK. We acquired the mutex. We're in here, so if the Modeless dialog thread wants to access this variable, it won't be able to, as long as it's guarded everywhere. Now I want to check to see what that value is. Well, mi-ret code, this here, Modeless dialog, this encoding code, not interpreted this correctly because I'm in this thread. I'm going to switch threads here. Here's mi-ret code. Currently, the value is that, and that's just random garbage. CD. In fact, I should be setting that. I'm not initially setting it to anything, so it's my fault. But anyway, it's not going to be equal to -1. Back to where we were. See, the thread that we're actually calling this function from Now it's got it correctly. Okay, here's the thread. But okay, here, mi ret code, m of t is this. Now this comparison, when I do F8, takes me properly to here. And that's all I wanted to show you. And it's not equal to -1. If we're not in the thread, oh, I see. So it's good that I've gone through this. This should be true. We're not in the thread. And I'm tracing a warning. Sync stop request ignored. And I'm just returning. And the warning tells me that I'm not processing that. And the reason is that I haven't correctly initialized this to -1. Right? But it thinks that this has already been set by someone. -1 is supposed to indicate that it hasn't been set yet. So the bug is not in this code, but in that I haven't correctly initialized this. And that should have been done in the constructor of Modeless Dialog. In all of these cases, I can do it the more natural way. Just copy that. -1 means uninitialized, right? But it truly was uninitialized in the sense of no default initialization. So if I run the same experiment yet again, this time it should not ignore it. It's equal to -1, which means that nobody has set the return code. The reason I can do this is because I have a constructor for that takes an argument of type t. This doesn't come for free. It's not an int, it's a structure. Alright, open small file. Okay, so now it's getting it correctly. That's good. Why is it saying not -1? Well, it's got to be a bug. Maybe it didn't. It probably didn't pick up. I probably have to do a clean. With these template things, you've got to do a clean build. Oh, that's why. That should be a comma, not a colon. It shouldn't have compiled at all. I want to see it compile. You can put colon then colon again. Come on, let's see the. Well, what does colon and then colon mean? this is the, oh, it wouldn't have compiled that part because it's a template, see? Only when I make use of one of these things will the error show up. That will occur when it tries to compile Notepad Cubed. That's the other thing about templates that's one of the, I would say it's sort of a bug, a compiler bug. The code written, even though it wasn't being used, was incorrect. And I think that the compiler has enough, should have enough resources available to find a template bug, even if it's not instanced. But, I don't know, maybe not. Maybe it's just impossible. It is good though, actually. You could take advantage of that fact, right? If you don't want a particular type to be used with a class, all you got to do is make a template constructor, let's say, that has an error in it. If they try to use the wrong type, right? Let's say you don't want int, so you say template blah 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 of int, and put an error in that one. Will that get instance? You could somehow work it out, I'm sure, pretty easily. Put a template assertion by creating an error, as I've shown you before, that occurs if the wrong type is used. Okay, now I'm going to spray. Stop. Alright, I just got. Okay, I just didn't want to wait for it. Now it's correct, it's -1. Okay, it's just a compiler thing. Alright, so now you'll see that assignment takes us to here. Double equals, use this one, equals, uses this one. And so it acts in every way like a regular old int, but it's got that extra protection. If we're not in the thread, we'll just trace that out as a message. Sync stop requested. This is what I call sync stop, I guess. Synchronous. And now synchronous means is like a Marshall type thing. We're going to post a quit message to our hwin, okay, and then we're going to wait for the thread to terminate. Terminated, and it's not active. Okay, and here we are asserting it again. Don't need the assertion. Delete should be fine, and everything should be fine. It turns out we don't need that assert. It's been asserted. Okay. Now, if someone presses OK, and it's not from outside, not the outside world doing it, but from within, on WM command ID OK, and we get to here, this will be set, and this will return true. We are in thread. This won't happen. So we'll be in this clause. This is an asynchronous, called an asynchronous stop, in which case we can't wait for ourselves to quit because we are ourselves. We just post the message and let things fly. Okay? And if somebody tries to quit again, kill it again with a different return code, from outside or inside. I'm just tracing out these warnings. Ignore. Okay, so in a nutshell, there you go. Modeless dialog, multiple thread dialogues, the fact that we're doing it wrong in the first place, and now I'm going to do it right. See you.